We're going over how to carry out arithmetic computations on infinity and infinitesimals. Alright, so first things first, we want to note what the forms of infinity and infinitesimals are. Alright, so let's go ahead and write this down. Note the forms of infinity and infinitesimals. Let's start with the forms of infinity. Now, infinity, depending on the sign, represents the biggest real number or the smallest real number. Alright? So let's give ourselves a visual on a number line. What on the earth is infinity? Let's capture that on a number line. So right there at the center you have 0. The biggest possible number is known as infinity. It's on the right end of the number line. And the smallest possible number is known as negative infinity and is at the left end of the number line. Okay? So positive infinity is captured by this symbol, and it can be written in numerical form. The numerical form that we'll be using for infinity in this class is 1, 0, 0, an infinite number of zeros, 0, 0. So we're just going to use this representation just to capture it. So think about infinity as 1 with infinite number of zeros. Okay? So this basically is the biggest possible number that exists in the world. And then negative infinity is the opposite of that. Negative 1, 0, 0 with an infinite number of zeros, 0, 0. Okay? Now this is infinity. Now we're going to take a look at the other side of it, known as infinitesimals. Infinitesimals. Okay? So if you think about infinity and negative infinity as large positive, large negative, extremely large positive and negative numbers, think about infinitesimals as extremely small. So infinite decimals, extremely small, infinitely small positive and negative numbers. Okay? To give you a visual perspective on this, let's put it on a number line. So if you have a number line, now if you want to get really, really small, what you're going to be doing is getting arbitrarily close to 0. Okay? So you can approach 0 from the left, or you can approach 0 from the right. Okay? So from the right, you have 0 from the right. This represents the smallest real number. Okay? And then 0 from the left represents the biggest negative number. Okay? Think about this as an extremely small positive number, and this as an extremely small negative number. Okay? Let's go ahead and represent these. Now, the interesting thing about infinitesimals is they're fractional, so you can write them as decimals or fractions. Okay, more representations than this one right here. So let's take a look at 0 from the right. This is the smallest positive number. Okay, 0 from the right. This is in decimal form. You can write this as 0.00, and guess what? An infinite number of zeros, 0, 1. Okay? Now this guy right here can be written as a fraction. Remember, every decimal can be written as a fraction. So if you want to write this as a fraction, it's going to be 1 over 100 with an infinite number of zeros, 0, 0. all you do is put this over 1 and you move the decimal point to the right. So if you move the decimal point to the right infinite number of times on the top, the same applies to the bottom, and you end up with this guy right here. Now let's pause for a second. 1, 0, 0, infinite number of zeros is another way of writing what? Take a look at up here. So 1 over 1, 0, 0, infinite number of zeros is the same thing as 1 over infinity. So what this is helping us to see is that 0 from the right and infinity are related. They are reciprocals of each other. If you reciprocate infinity, you end up with 0 from the right. If you reciprocate 0 from the right, you end up with infinity. So that's the relationship. Now, how about 0 from the left? A really, the biggest negative number, okay? Or really small number with a negative in front of it. So this one is just like that, but just throw in a 0 in front, a negative sign in front, 0.00, an infinite number of zeros, 0, 1. This is a decimal point, just decimal form of the negative infinitesimal. This decimal format can also be written as a fraction. So in fractional form, it's going to be like the top, but you'll have a negative sign. So it's negative, or we can write it like this. There are different ways you can position the negative. So you can write it as 1 over negative 1, 0, 0, infinite number of zeros, 0, 1. If you have negative 1 with infinite number of zeros, 0, 0, sorry, this is the same thing as what? Negative infinity. So this helps us to see that 0 from the left is related to negative infinity. They are reciprocals of each other. Alrighty? So let's go ahead and summarize what we just have written up here. So summary. 0 from the right is the same thing as 1 over infinity, and infinity is the same thing as 1 over 0 from the right. 0 from the left is equal to negative 1 over infinity, and negative infinity is the same thing as 1 over 0 from the left. Okay, so that's that. Now just a side point. Whenever you have, if you have something like this, 1 over 0, 1 over 0 or a number over 0 is defined or is described as being undefined. Now why is that the case? The reason why 1 over 0 is undefined is because it represents two numbers. So this, since it doesn't have a sign, you assume that you're coming from the left and right, and this is equal to positive or negative infinity. So 1 over 0 represents positive infinity and negative infinity, so which one are you going to pick? You can't pick any one, so that's why it's described as being undefined. But if you want to be technical, the answer is actually plus or minus infinity, if the direction is not specified. Okay? Now let's try out some exercises using infinitesimals and infinity. Question number 1. What is 5 minus 5 from the left? Alright, let's go ahead and solve it. 5 minus 5 from the left. Now, 5 minus 5 from the left, if you think about it, is going to be 0 from the left. But let's go ahead and show the work, okay? So 5 is just 5. 5 from the left basically means you're getting really close to 5 from the left side. So if you're getting really close to 5 from the left side, it's going to be 4.99, infinite number of 9s, 99. Okay? So this is 5 from the left in expanded form. Now what happens when you subtract 4.999 with infinite number of 9s? If you subtract it from 5, you're going to end up with what? Exactly. Okay, so we're going to have, if you subtract it, you have 0.00, an infinite number of zeros, 0, 1. Okay? Now this expanded form can be written as 0 from the right, or if you want to write it using infinity, 0 from the right is the same thing as 1 over infinity. Question number 2, what if we were to find -7 from the left plus 7? What is this one going to be? Well, let's write down this -7 from the left in expanded form. -7 from the left on the number line is -7.00, an infinite number of zeros, 0, 1 plus 7. Okay? So you're subtracting here. The signs are different. You subtract and keep the sign of the bigger, so our result will be negative. Okay? So when you subtract these, you know the 7s cancel out, so you have -0.00, an infinite number of zeros, 0, 1. This can be written as 0 from the left. That's the infinitesimal representation of this, or -1 over infinity. So for question 3, let's say you were to compute 8 plus 8, well, let's do -8 plus 8 from the right. Okay, so something like that. Alright, so let's go ahead and represent 8 from the right on a number line so you can see exactly what's going on. So this, we don't know what it is yet. So on the number line, 8, this is 8 right here. And then to the right of 8, you have 8.01, you have 8.1, and it goes on and on. Okay? So when you're approaching 8 from the right, is as though it's basically 8.00, infinite number of zeros, 0, 1, when you're approaching 8 from the right side. And then from the left is 7.99, infinite number of lines from the left. Okay, so that's 8 from the right. Let me just put it just for kicks. And then if you're coming from this is for the right. If you're coming from the left, 8 from the left is 7.9, infinite number of 9s, 99, because over here you have 7.9, 7.99, and as you get closer to 8 from the left, you have more 9s. Okay? Alright, now let's input that into our computation here. So you have -8 plus 8 from the right is going to be -8 plus 8.00, an infinite number of zeros, 0, 1. So that's going to give us, you subtract these two and keep the sign of the bigger, 0.00, an infinite number of zeros, 0, 1. This is the same thing as 0 from the right, or 1 over infinity. Now what if we have a quotient situation? This one involves dividing. For problem number 4, what if we are to find 1 over 2 minus 2 from the left? Okay? 1 over 2 minus 2 from the left is going to be 1 over 2 minus 2 from the left on the number line. You're getting really, really close to 2 from the left. So let's say that's your number line. You have 2 right here. 2 from the left, this is 2 from the left. Okay? So from the left, you have 1.9 you have 1.99, and you keep having more nines as you get close to 2 from the left. Okay, so 2 from the left is 1.99, infinite number of nines, 99. When you subtract these two, you're going to end up with 1 over, that's going to be 0.00, infinite number of zeros, 0, 1, which is equal to 1 over 0 from the right. 1 over a very, very small positive number is equal to, is the same thing as what? Infinity. For number 5, let's say you have 1 over negative 3 from the left square minus 9. Now what's this going to be? If you compute 1 over negative 3 from the left square minus 9, you're basically looking at 1 over negative 3 from the left. The left side on the negative side is going to be negative 3.00, infinite number of zeros, 0, 1. You're going to square that and subtract 9. If you do this in your calculator, what you will get is negative 3.00001 square is going to be positive 9.00, an infinite number of zeros, 0, 1. So when you square a negative directional number, the sign and direction change. Something to keep in mind. Minus 9, this becomes 1 over 0 from the right, or infinity. Okay, so that's that.